This video is to work through some examples from our 8.6 through 8.8 notes in Math 120. We're going to look at example 3 first. Suppose that you decide to buy a car for $50,000, including taxes and license fees. You saved $8,000 for a down payment. The dealer is offering you a choice between two incentives. Incentive A is $4,000 off the price of the car, followed by a 4-year loan at 5.25%. Incentive B is no cash rebated, but free financing, which means no interest over 4 years. What is the difference in monthly payments between the two offers? Which incentive is the better deal? In order to answer these questions, I first need to actually find the monthly payment for each incentive. I'm going to focus on incentive A first. That problem told us that the original price of everything was $50,000. But with incentive A, they take $4,000 off the price of the car. And in both of these cases, we've saved $8,000 for a down payment. If I'm trying to find the principal, I need to take the price of the car, that $50,000, subtract the down payment, because I'm not going to have to take out a loan for that, and subtract the $4,000 that they're just knocking off the price of the car. That tells me that my principal is going to be $38,000. Now I get to use that payment formula. That formula is payment equals the principal times the rate over the number of payments per year, all over 1 minus 1 plus that same fraction, all raised to the power of negative n times t. In this case, my principal is $38,000. If we look back up at incentive A, the rate is this 5.25%. Remember, I need to write that in decimal form. They also tell me up here that it's a 4-year loan. So my rate was 0.0525. That n, because they're asking for monthly payments, is 12. I have 1 minus, 1 plus. My rate is still that 5.25% in decimal form. I'm still making monthly payments. And I have the negative 12 times 4 for the 4-year loan. When you plug that in the calculator, we all get 879.4230845. Remember, we always need to round these to dollars and cents. 2 is in the hundredths place. 3 tells me to round down. So that rounded monthly payment is going to be $879.42. That gives me part of the answer for this first question. What is the difference in monthly payments? I found the first monthly payment. Now I need to go through this same process for incentive B. If we're talking through the principal for incentive B, the price of the car has not changed. It's still $50,000. So I'm going to start out with that $50,000 again. We still have our $8,000 down payment. And if we look back at incentive B, there's no cash rebate. So the only thing I'm doing is subtracting that down payment. That means my principal is going to be $42,000. The benefit of this one is that there's no interest. It's still over 4 years. So my T is still going to equal 4. If I try plugging everything into my payment formula, my principal is $42,000. If it's 0 interest, even if I bump that decimal point over 2 places, I still end up with 0. Over n, I'm still making 12 monthly payments, all over 1 minus 1 plus my 0 over 12 raised to the power of negative 12 times 4. Now, if you plug all of that into your calculator, you just get 0. Think through this numerator. If we do 0 divided by 12, we're going to get 0. If we do 42,000 times 0, we get 0. And 0 divided by anything is just 0. So it would be very nice if they would just give us this car for free, if our payment was actually $0. But unfortunately, that's not going to happen. So this equation does not work. And it's because that principal, or I apologize, that interest rate is 0. What we do instead is use logic. If we have to pay a total of $42,000, but pay absolutely no interest on it, it means that we are only paying back our $42,000. We have to divide it then by the number of payments. The way we find our number of payments is by doing the number of payments per year, so 12 because we're paying monthly, times the number of years. That means we need to do our $42,000 divided by 48, our 12 times 4. If we do that, we find that the payment in this case is $875. So we're closer to answering that first question. What is the difference in monthly payments? Remember, difference is a key word for subtraction. So what I'm going to do is take my first payment, because it's larger, $879, and 42 cents, minus $875. We find that the difference in monthly payments is $4.42. The other thing they asked us was which one is the better deal. The better deal is incentive B, because it has that lower monthly payment over the same time period. The next example we're going to look at deals with houses and mortgages. In terms of paying less in interest, which is more economical for a $350,000 mortgage? A 30-year fixed rate at 8% or a 20-year fixed rate at 9%? How much interest is saved? Just like the last example, they're giving us two different things here. So I'm going to have to go through and find my payment 2 different times for the different information they gave me. In this case, we're looking at our $350,000 mortgage. And the first thing I'm going to focus on is this 30-year fixed rate at 8%. So I don't get them mixed up, I'm going to label my 30 years. I'm going to use that payment formula again. The principal times R over N, all divided by 1 minus 1 plus R over N raised to the power of negative NT. The principal is that $350,000. They did not say that's the price of the house. They didn't talk about any down payments. It is the mortgage, so it is the principal. The rate was 8% in decimal form. That's 0.08. We always assume a monthly payment if they don't give us any information, so I'll say that N is 12. 1 minus our 1 plus. The rate is 8%. Our N is 12. Raised to the power of that N times T. It's a 30-year mortgage, so our T is 30. When you plug that into the calculator, you get 2,568.176009. Remember, we want to round to the nearest cent. That 6 tells us to round up. So our payment is $2,568.18. But they don't ask us which one has the lower payment. They ask us how much interest is saved. So I'm going to try to figure out the interest that I have to pay if I get this 30-year mortgage. The first thing I'm going to do for that is figure out the total amount I pay towards the loan. To do that, I'm going to take that rounded monthly payment. Make sure you use that rounded one. Times the number of payments I make. So my N times my T. If I do that, the total amount I pay on the loan is $924,544.80. That should come out exact. There should not be any rounding. If you did have to round, it meant you use that unrounded payment number, and you're going to have a rounding error. They didn't ask me to compare the total amount I paid on the loan, though. They asked me to figure out the interest. So to do that, I take the total amount I paid, that $924,544.80, and I subtract the actual amount that I borrowed, that $350,000. And if I do that, I find that the interest on this 30-year mortgage was $574,544.80. More money than I actually borrowed. Now, I go through that same process for the 20-year mortgage. So the 20-year mortgage had a little bit higher interest rate. It was 9%. So I'm still going to go through and use my payment formula. The principal has not changed. It is still a $350,000 mortgage. The rate, because it's 9% in decimal form, is 0.09. I'm still assuming that I'm making a monthly payment. I have 1 minus, 1 plus, the interest rate over N, raised to the power of negative N times T, which is 20 this time because it is a 20-year mortgage. If I do that, I end up with 3149.040845. I still want to round to the nearest cent. My 0 tells me to round down. and I get that the payment is $3,149.04. Just like before, I need to find the interest. I do that by first finding the total amount I pay towards the loan, which is that monthly payment times the number of payments. So I paid monthly for 20 years. That gives me $755,769.60. To find the interest, I take that total amount and subtract that principal amount that I actually borrowed, the $350,000. That tells me that the interest I pay here is $405,769.60. If we look back up, when they were asking us about the interest, they asked us how much interest is saved. So that means we need to find the difference between the two total interests. We ended up paying more interest on the 30-year loan. It was over $500,000. So I'm going to do that higher interest rate minus that lower interest paid. So if we're trying to find our interest saved, I'll do that $574,544.80 minus the $405,769.60. And that tells us that we save $168,775.20 with the 20-year mortgage. So even though that interest rate was a % higher, because of those 10 fewer years, we end up paying less interest.